Okay, so I left you with this example problem, and we were talking about benzoic anhydride. How do we draw benzoic anhydride? And if you took a few minutes to Google and cheat, then you're going to see that what you cheated probably is going to work out because you got the correct answer. But if you did not cheat, and if you did not use something like Google, then folks, let's kind of break this down and see why this structure is called benzoic anhydride, because it's one of the times that people do get confused with the nomenclature because it's almost like a trick. So anhydride. Okay, well, we know at this point anhydride is a C double bond O, O, C double bond O. All right, there you go. Benzoic. Okay, well, I know that benzoic is probably going to have a benzene ring. And there's only one benzoic listed. I mean, it's not called benzoic anhydride. Okay, so that probably means that the same structure is on each side. And that's exactly what this structure is. So now you're probably thinking, well, wait a minute, why is this a trick? Or you might be looking at your structure and you might be saying, oh, well, I added an extra carbon. Okay, well, let's talk about why that happens. C double bond O, O, C double bond O. That is the anhydride functional group. And back when we were talking about benzenes, well, if you remember, all right, here's the long carbon chain. And then off of this long carbon chain, we could have a benzene that's directly attached, or we could have a benzene on a middle carbon that's directly attached. And these two things were called something different. Well, in the first case, this one was called a phenyl group, PHENYL. And in the middle one, the middle carbon, middleman, this one was called the benzyl group. So we would write a number and we would put phenyl, or we would write a number and we would put benzyl. And all of that really deals with whether or not a carbon is serving as a middleman between the two structures. Well, if you look at this, you might say, well, wait, this is a benzene directly connected to this anhydride. Okay, well, that's the trick. That's what people fall for every time with this one. There's no such thing as a phenoic anhydride, because really what this boils down to is that this benzene ring, we are including that carbon somewhat as a middle man. And that's where this term benzoic is going to come from. So this is the structure for benzoic anhydride. And where people mess up is that they will add an extra carbon in between the anhydride piece and then the benzene, because they think that this is the benzyl group. And folks, that is the benzyl group, but the carbon is already present. Another way that I can maybe make you not fall for this trick is think about this Iupac name. We have typically been dropping E's from these names and adding oik onto the end. And if we drop the oik from benzoic anhydride, we would end up with something close to benzene. So there is the E ending. So we need to draw benzene onto the left and onto the right of that structure. So there's your structure for benzoic anhydride. All right, now we're going to move on. We're going to move on to our next functional group because we've got a lot of things to talk about, folks. So let's speed it up. And our next one will be esters. Okay, so what is an ester? Well, an ester functional group is a carbon double bond O with an O. That's the ester group. That's what we're going to be looking for here. Well, we've got something random that will be over here on the right-hand side, and we've got something random that will be over here on the left-hand side. So they're going to be flanked with two alkyl groups or some type of carbon-based group on either side. So C double bond OO, that is an ester. Very important. There's tons of different esters, and they do everything from smell like glue to smell like pineapples. They're great. They're wonderful. depending on what you like to smell and sniff. Some people think gasoline smells good. I'm not going to tell you to go out and smell gasoline, but some people think that glue smells good too. Ask the kids back in the 80s when they decided to hoard up in their garage and keep the doors shut while they got high off of glue sniffing. That's just kind of the things that happened. And again, I don't encourage you to do that. No, I'm not. But that is one of the things that was going on, and it was the ester smell that they were going for. All right, so this ester stuff, C double bond OO. Okay, there's cherries and pineapples, bananas and lemons, everything that I can imagine. Grapefruit scents, tons of it in your colognes, tons of it in your perfumes, tons of it in your shampoos, your conditioners, your lotions, your lip balms. All of those are esters based because typically they do smell pretty darn good. So we're going to have to learn how to name them. And how do we name esters? Well, we have to do a proper ending. We know that. So the ending here with ester is O8. So OATE, that's going to be the modified ending that we're going to have. So here in the front, we're going to have to question, what is that? And we'll get to that in just a second. But the problem here is that with ester groups, there are two alkyl substituent groups that are onto the esters. So what I mean by that is that this right-handed piece is going to have to be named. And this piece will also have to be named. And they do not have to be identical, folks. They do not have to be the same. Meaning I could have on one side a 3-carbon chain, and on the other side I could have a 4-carbon chain. Or on one side I could do 1 carbon, and on the other side I could do a ring substituent. So we're going to have to figure out which one comes first, right? Okay, so we're going to talk about Iupac names. We're also going to talk about common names, though. And what you're going to realize is that common names, like some of the other carbonyls, really do have a preference in a laboratory field. In a real working environment, we often gravitate toward the common names here, and it drives Iupac crazy, but folks, sometimes that's just the way that it is. All right, so let's kind of do an example, and let's name it together, and I think that you'll pick up on this quite easy, and you'll be like, okay, I'm ready for the next one. There's nothing hard about this. All right, so here we go. There's a structure. So here's the rules to name an ester. First, you're going to find the ester. Okay, right here's the ester. Right there. I'm going to circle it for you. Number 2, you are going to name the group that's attached to the oxygen first. So that means we have to name that piece. That 2-carbon chain is directly attached to the oxygen. Notice on the other side, this piece is connected to the carbon of the carbonyl. We do not name that first. So we need to figure out really our bearings here for a second with esters, because we have to look for that oxygen. Wherever that oxygen is, we look at what's connected to that oxygen, and we name that piece first. So a 2-carbon chain is called ethyl. All right, so it's still called ethyl here. There's no difference. Iupac makes you happy. Now, what I need to do is I need to look on the other side of that ester group, and just like Iupac always states, you find the longest carbon chain that includes the functional group. All right, so what I'm going to do now is I'm going to erase this because this was our ester focus. I just wanted you to look at this for a second. And we now know to name the piece that's on the oxygen first. And now we need to look at this carbon involved in the carbonyl. This is my number 1 carbon right there. That's where my functional group is. That's where that carbon is. That's where the longest carbon chain starts. It's right there. And I need to go to the left because that's going to be my main parent chain. So there's 2 carbons here. And those 2 carbons normally would be called ethane. There's carbon number 1 and there's carbon number 2. However, in Iupac nomenclature for esters, we erase the E, and what we do is that we add the ending OAT. Ethyl ethanoate. That is going to be the Iupac name for this structure. So, recap, always name the group to the oxygen first, then you name the longest carbon chain, and then you modify the ending to O8s. O8s are always going to be esters. That's what we're after. That's what we're looking for. Okay, well, that's the Iupac name. We can common name this as well. So when we common name it, we're going to go in for this particular structure, and we're still going to name the group on the oxygen first. And we're still going to name it the same way. It's still going to be called ethyl. And then over on the right-hand side, we're still going to look at these two carbons involved in the parent chain, but I don't use ethane because ethane's really more prim and proper. That's the Iupac. I've got to think, what was that common term for two carbons in a row? Well, I hope that you're going to tell me ACET, acetate. That's kind of what we've been seeing all along. I mean, we saw this with carboxylic acids. We called it acetic acid. Acetyl chloride for those groups that had C double bond O with a C on it, right? Then we saw acetic as far as anhydrides go, because they were kind of named the same as carboxylics. So how on earth do we name common names using these endings very similar? We just don't add the O. We leave that O off. So this is going to be 8. So the Iupac name is going to be ethyl ethanoate, and then the common term is still ethyl. There's no change. Acete for the two carbons, and the modified ending of 8. We just leave off the O. So ethyl acetate. That is what we're after. That's the common name. And folks, out of these two choices, in a laboratory, all day, every day, people would be talking about ethyl acetates over ethyl ethanoates. That's just the way that it is. Common name, once again, is truly common in the world of carbonyls, and we still use them. We use them like crazy every single time. All right? Okay, so let's do another example. Let's try CH3, CH2, carbon, double bond O with an oxygen, and then a benzene ring that is attached to that. Okay, so let's use what we've always have done. Nothing new except the modified ending, and we should be able to come up with a name for this thing. All right, so I'll look at this structure and I find the ester group, and right here's the ester group. It's right there. And then the rules just told me I named the group that's attached to the O first. Okay, well, that's this piece. We have to name that piece. And you're going to write down benzyl. Wrong. That's not right. Because that benzene is directly connected to the oxygen and there is no middle carbon. So this is not a benzyl group. This instead is a phenyl group. PHENYL. Phenyl. There we go. So this goes back to that traditional, that benzene is directly connected to the main chain with no carbon that it's connected to in the middle. So we call this phenyl. Okay, so there's that piece. Now on the other side, what do I have? Well, here's my carbonyl, so that's carbon 1, carbon 2, and carbon 3. So 3 carbons, what do we call a 3-carbon chain? We call it a propane. However, I drop the E and I add O8 onto the end. So we're going to call this phenyl propanoate. Now, let's look at a common name. Common names, I do the same thing. That benzene group is still going to be called phenyl. There's no difference. 3-carbon chain, what do I call that? Oh, well, we said that we call that propion, right? Propion, there you go. And then we said that we bring in not O8, we just leave that O off, and we add ATE. So this is phenyl propionate. So phenyl propanoate and phenyl propionate. Those are the differences between the Iupac and the common name. Okay, let's keep building. Let's keep getting more and more complicated here. Let's do C double bond OO, and we'll do a CH3 on this side. And then here, let's do a CH2, a CH with a BR, and then a CH3. All right, Iupac it. Okay, no problem. I got this. I know you got this too. So I find the ester group. There's the ester. I name the thing on the O. Okay, well, there's a CH3 there. So this is going to be called methyl. See how easy. Now I'll look on the other side and I find the longest carbon chain. All right, so there's carbon 1, there's carbon 2, there's carbon 3, there's carbon 4. So that means that this is a butane. Drop the E and add O8. Okay, well, that's great, but we're leaving off something. What are we leaving off? Well, we're leaving off that bromo group. I mean, I can see that. We didn't put bromo into the name. Well, that bromo, according to Iupac, is on carbon number 3. So we're going to have to put a 3 in here somewhere. Okay, so 3 bromo methyl butanoate. Right? I mean, is that good enough? And the answer is, for me, it is. I give you credit for this. Not a big deal. However, if we want it to be proper, what happens with the names of the ester is that the group on the O is always named first. Every single time it's always named first. So that means, in actuality, this is really called methyl, because it leads me to believe that methyl is on the O, and then 3 bromo would come next, and then butanoate. Another way that you need to regard this is if you wrote 3 bromo first and I see the O8 ending, it's almost a trigger that that 3 bromo group would be on the side of the oxygen, and it is not. It's on the other side. So that is one of the templates that Iupac really encourages you to do, but in here, there's so many rules and there's so many regulations, and it's the first time you're learning it, and all of this begins to just wrap up together in one big lump mud ball. And I just go ahead and give you credit if the pieces are there. I give you the benefit of the doubt, all right? But in Iupac, you always name the group on the O first, in this case methyl, and then you worry about everything else on the left-hand side in this case, and that bromo needs to go with that butanoate part, because that's the side that bromo is on. So that's why we write it closer together. So methyl 3 bromo butanoate. That is the Iupac name for that ester. Now, this does have a common name. Let's work through that common name for a minute, because this could be a trick. Okay, I named the piece on the O, and that piece is a methyl. There we go. Methyl. Now I need to name the other side, and the other side is still a 4-carbon chain. Okay, so that is a butyr, right? That's what we've always used. I need to add the ending. So instead of an O8, it's an ATE. So butyrate. That's going to be the ending to this molecule for the common name. And now I need to go in and I need to work the bromo in. Okay, well, you might look at this and say, well, it's still on the 3rd carbon. So 3 bromo butyrate. Wrong. In common names, folks, we've seen this before in the carbonyl family. If you are naming it as a common name, they really do not like for you to use these numbers. So there's got to be another way that we can go in and substitute the number for something in the common nomenclature. We've already done it. We did it when we talked about the Greek alphabet. You might have forgotten that already. But we went through and named things with alphas and betas and gammas and deltas. Well, in order for this to work the proper way, if you go back and review the common nomenclature system, This carbon in the carbonyl does not get a Greek letter. That's where the trick is going to happen. A lot of people give this the alpha. That is not the alpha. The one beside of it is the alpha group. So that's the alpha, that's the beta, this is the gamma, right? I mean, that's kind of what we said. And it still holds true here. There's no difference. So if this is alpha, this is our beta carbon, and this is a beta bromobutyrate. So the common name is methyl beta bromobutyrate. The Iupac name is methyl 3-bromobutanoate. That's your nomenclature for an ester. All right, now we're going to do one more. And here, let's do a C double bond OO. And then on this side, we'll do a CH2, CH3. And then on this side, let's just do a ring system. No benzene, just a ring. Okay, well, Iupac it. All right, so the Iupac name, I find the oxygen, there it is. And then beside the oxygen, I've got an ethyl group. So this is a ethyl. I know it ends in 08. What kind of 08 is it? Okay, well, over on the left-hand side, my ring system is really the main chain here. Well, that ring is a cyclohexane. And you're going to see something similar, what we do here, as what we've always done when rings are the really parent name. We name the ring as a whole. This is cyclohexane. I do the whole thing. And then I need to include the name of that piece right there. And that is an ester. I know that. But it is a carbonyl. So CARBOXY for oxy, oxygen. And then ATE, carboxylate. That is what we're going to name this. An ethyl cyclohexane carboxylate. So carboxylates are basically the carbonyl, C double bond O, and then that oxygen is the oxy part of the carbonyl. It takes both of those to make that group up. And that is how we represent that in the name when we have a certain ring like this one over on the left-hand side. Now, something else that I also want you to be aware of is that we can have esters like this, or we can have salts of esters as well. This is also something very common in the ester field. So a salt of an ester is just basically this concept that these organic molecules are really ions. They are positive and negative charges. So the positive charge will typically come from things like sodium or potassium, and then the negative piece will come from the remaining ester part there at the very end. So on your esters, your C double bond OOs, remember I said that this is an R group and this is an R group. Okay, well, we can cleave this piece off sometimes. And what esters tend to do, if we do that, there's no carbon that's there, this will carry with it a negative charge. It's perfectly okay. The reason that that's perfectly okay is because that oxygen can take those extra electrons and it can shove them to that carbon, which shoves them to that oxygen, and we get delocalization. Look at this. It's a pi set of electrons that can move toward a double bond. This was the whole part of delocalization back in Chemistry 251. So delocalization can happen within this molecule. Stabilization can happen. This molecule becomes very happy because of it. But if this carries a negative charge, we have to have something to balance out that negative charge. So instead of a carbon-based piece over here, we can have a sodium that could be over there. Or we can have a potassium that can be over there. Those aren't the only two, but those are the most common. They are the cheapest. They are the most common for us to order and to use in the lab. And you actually used one of these if you have had me for Chemistry 251, because one of the very first labs that we did was a pH of a food preservative. And that pH of a food preservative lab focused on a molecule called sodium benzoate. So I now know sodium in a benzoate. Oh, look at that. 08. So I know that this is an ester and there's probably a benzene. So folks, there you go. And that structure is actually on your screen to the right-hand side. So let's take a look at how to name these. We name them just like before. There's really no difference in them at all. So we name the piece on the oxygen first. So that is a Na for sodium. And then over here to the left-hand side, there's only one carbon of the main chain. So that's methane. We drop the E and add O8 onto that ending. So sodium methanoate. I do the same thing for the middle one. This is an oxygen. There is my potassium. That's connected to the O. So potassium is going to be named first. And then this is a 2-carbon chain, so ethane. And we drop the E and add O8, so ethanoate. And then finally here, the Iupac name, I do it the same way. There's the oxygen. So sodium is connected to that. I named that first. And then this one's one of those that has this weird ring system that we name a little bit different. So I named the entire ring as a whole. So that's benzene. And then this C double bond O piece, that is called carboxylate. We did it with carboxylic acids. We do it over and over every single time that we see them. All right, so nothing really new there either. It might feel a little strange. It might feel a little uncomfortable. And if so, I completely understand. But it is something that we have seen before. All right, so those are the Iupac ways that we name them. Common ways, folks, there's no surprises here. I named the Na first. That's sodium. What's the common name for a 1-carbon chain? It's form. And then I add the ending 8. So sodium formate. Same thing here. I say potassium first. And then a 2-carbon chain is acete, ACET. And then I add the ending 8. And then here for a common name, I name sodium first, just like before. And then what do we name this whole thing? That's called a benzoate. So sodium formate, potassium acetate, and sodium benzoate. All right, so that's the story with normal esters. That is the order that we name them. That is how we name them. Those are the endings that go along with them. But we're not quite done with esters. And the reason here is because esters can do something a little funny to us. This C double bond OO. What if we have some carbons out here, and what if we have some carbons out here? That's great. We can name these like that. That's not a problem. However, these bonds and these atoms are in constant movement. I mean, that's something that we learned in Chemistry 251. And with that said, because they are in constant movement, well, they could twist and they could turn around and they could hook up with each other and say, hey, hubba hubba, right? So what I mean by that is carbon involved in the ester group could actually swing some carbons all the way around and connect back to itself. I mean, this doesn't need two to tango. This is perfectly okay on its own, in the privacy of his or her own home. This molecule is completely happy. So if this molecule turns around and latches onto itself to make this ring system, well, all of a sudden, we have an ester group, but that ester group is part of a ring. If it's a part of a ring, and it's an ester, This is a different type of functional group. It is ester related, but it's a different type of functional group. And this functional group is called a lactone. Lactone, lactone. So the "one" ending is slightly coming from ketone. And ketone is a C double bond O. So lactones have their own nomenclature system as well. So these are esters. They are a different type of ester, a subclass of esters, if you want to think of them that way. And the lactone is similar to how we name them, kind of in ester groups. But there's just another modified ending that comes along with these. So in the next video, we're going to learn how to draw lactones and how to name lactones, and kind of give you some tidbits of information about where tricks are going to come in that they might throw your way when lactones are concerned. So, esters, they can show up in rings. These rings, the way that you're seeing them on the screen, these are called lactones. And to name them, we follow another rule set of Iupac. Yes, I know, I told you, right? Tons of functional groups. We just, again, blaze through them, one functional group after another, after another, after another. One nomenclature set, another, after another, after another. Folks, that's just the way that carbonyls are. And that's one of the reasons that I keep it to the very end. So, in the next video, we'll look at lactones. We'll learn how to name them the proper way. And we'll just kind of keep working through the nomenclature system. We don't have that many more to go through. But lactones is going to be a barrier until we get over it.